Hello, this is Moody, and I wanted to give kind of a brief crash course on how authentication works in Plan 9. I hope for this video to serve as a good jumping off point for those interested in learning how auth works and all of the moving parts involved with it. The core part of Plan 9 auth is Factotum. Factotum acts as an authentication agent and a password manager. Factotum is exposed to the user and programmed through a 9p file system mounted at /mount/factotum. So let's take a look in there and see what we find. So the first file I want to take a look at is CTL. And we see in CTL, this is all of the different credentials that I have loaded into Factotum. So we see stuff like a SSH private key, information for other users within my auth domain. We can take a look at mercurial passwords that I have used set up for Bitbucket. We can also see I just have a straight password string set for IRC used for Nixer. We also see that there's this kind of proto string, and if we actually take a look at the proto file here, this lists all of the protocols that Factotum supports, so this proto can be any one of these defined here. You might also notice that certain fields here are prepended by a bang and postpended or appended by a question mark. So that's the actual secrets that are associated with the credentials. Programs can still get access to these credentials through use of the RPC file, and it's also very easy to add new credentials into Factotum itself. So I'll go ahead and just take one of these key strings here and modify it. So I'll make this test. Set the password to test. I do have to wrap it in quotes or else RC will interpret the equal signs as variable assignments, and we'll set that to CTL. And if we cat CTL now, we'll see that my new key value pair test is now in there, and likewise the password is not shown even though it was defined here. So how does this work from a normal terminal boot standpoint? So in the terminal boots, the Factotum binary is stored in the PACFS, which is a suite of binaries that are used early on by the kernel before it might have access to a disk file server. So Factotum loads, and Factotum is actually what assists in doing the initial authentication to a disk file server like CWFS or HJFS. It is also worth noting that Factotum can load initial state from something called sexstore. So actually, if we just try and load Factotum here, it's actually going to prompt me for my sexstore password. Oops, wrong password. There we go. And then if we check the CTL file now, we'll see that all of my other information that I had defined up here, the new field that I had, was or is not here now because Sexstore has a full CTL file that it has, including the secrets in there that Factotum will just load straight into itself when it realizes that the Sexstore is defined. Now, a Sexstore does require a corresponding Sexstore D. In fact, if we look at the Sexstore, I guess it's not defined here, must be defined. It is defined in the Plan9.ini, so when you're booting and that is defined, you can go ahead and connect to it, or the kernel will know to connect to it. And Sexstore is nice because it uses one password for connecting, and then it loads all the other information right into you. So it works a bit like modern password managers. You've kind of got one password to rule them all. You connect to it, and it gives you all your other passwords for various other services. Now for a CPU server, things work a bit differently, since the host owner is usually static. So when you first configure the CPU server, it will prompt you for information regarding the host owner, and that includes a Sexstore password. So when the CPU server boots, it can use that password that you stored when you initially set it up in order to load keys in for the host owner itself. So this allows the host owner to have a defined password even though that the CPU server is booting non-interactively. It is also worth mentioning the dev cap files. So if we take a look at which files are here, we see we have /dev/cap hash and /dev/cap use. So cap use is a special file that is opened only once. It is opened early on by Factotum in the boot sequence, and it is what processes use in order to facilitate a change of user, or what user owns the process. So if you take a look at which user I currently am now, I'm Moody. When I change into Glenda, verify that I am indeed Glenda, I am. So what this does is I actually negotiated with Factotum there, so my Moody user went up to Factotum. It provided that yes, I do indeed have the credentials for Glinda in this authentication domain. And then what Factotum did is it generated a SHA-1 hash, wrote it out to dev-cap-use, and then also provided it to me, the RC process, running, and then I presented that same hash to cap-hash, and at that point the kernel knows, hey look, he is verified and authenticated in order to speak on behalf of this user, so it allows my process to change running users. Factotum is also used heavily within 9P to facilitate authentication. So when you're first initialing a 9P connection, after you've communicated version numbers, the client will request a tauth request, and the server will respond with AFID, the AFID. Now, AFID is a special FID to the server in which all authentication is talked over. It's also worth noting that the server will also provide a authentication domain for which the server is a part of. So in practice, what happens is the client takes that AFID and hooks it up to its Factotum RPC file, and the server also takes it, hooks up to its RPC file. And the RPC file is how programs communicate with Factotum in order to get it to actually do the authentication agent portion of its job. So after the client Factotum and server Factotum have communicated with each other, and they've also communicated with the auth server potentially, the server then knows, hey, the client is attached, and the client says, hey, I'm probably ready to mount the server now, so it sends a T attach, to which the server responds with an R attach, which either says, yeah, here's the root FID, you're good to go, or nope, authentication failed, try again, or continue talking, or the AFID. To take a look at the actual auth server itself, the user secrets are stored in a file system called KeyFS, and other machines on the network can connect and negotiate with the auth server over authserve, which is a program that runs on the authserve, which is a program that runs on the auth server itself. Some additional quick things to note or to keep in mind about Plan9 authentication is that the 9P file servers will always run as the user that started them. So for example, CWFS runs as host owner. So when I'm connecting as Moody, a non-privileged user, the handling connection on CWFS's end is still running as Glinda, but it uses the information that it got back from the authentication handshake, the auth info struct, in order to determine which user I am and which access I have. So unlike Unix or Linux, where the only way to create a file that is owned by a user through the create syscall is by being owned by the user, or being owned by the same user that you want to be created as, in Plan9, the 9P file servers are free to do with the auth info as they wish. It's also worth noting that because of this 9P negotiation for authentication, when you change users, so like when I changed from user to Glinda there, it rebuilt my namespace based on the lib namespace file, which defines all of kind of the generic template namespace. And if we look at my namespace here, we see that I am changed into a new namespace, and we can even check the Factotum CTL file to see that indeed it is a different namespace. If you are curious and learning more about how these systems work, I highly recommend taking a look at the man pages that correspond to it. There's man pages for Factotum and the Factotum RPC. There's also man pages for taking a look at authserve, which will detail exactly how clients and servers talk to each other, and when they also talk to the auth server. There's also information in there about, of course, KeyFS and authserve that was worth taking a look at too. I'd also recommend perhaps reading through the Factotum paper. Might do a much better job than I am at explaining all of the fine-tuned details of how Factotum works. If you have any questions about any of this, feel free to try and contact me, and I'll do my best to answer them. Besides that though, thanks for watching.